In exercise 6.3.16, we are asked to construct a confidence interval for a population proportion. So our basic formula for a confidence interval for a population proportion is there on the board. Our p hat, we remember, is determined by taking the number of people in the sample that had the characteristic we were interested in and dividing by the total number sampled. So the number that believe in UFOs was 705. The total number sampled was 2,315. So when we divide those, we have our p hat. This is equivalent to about 0.305. Q hat, we know, is always 1 minus that p hat value. So 1 minus 0.305 is our Q hat, and that will equal 0.695. So in our confidence interval formula, we have our p hat, which is 0.305, plus and minus our critical value, which we'll get from the table, but we know from previous examples that it's 1.96, but I'll demonstrate on the next board, times the square root of our p hat, times our q hat, over our n. And when we compute this interval, we get the lower boundary by taking 0.305 minus 1.96 times the square root of 0.305 times 0.695 over 2,315. That gives us the lower limit of the interval, which is 0.286. And then we do the same to get our upper limit, except we just take plus the margin of error of 1.96 times that square root value, and we get 0.324. So we can say that we are 95% confident that the true proportion of all adults who believe in UFOs is somewhere between 28.6% and 32.4%. But now, how did I get that critical value? Well, I have to keep in mind that 95% confidence means that we're capturing the middle 95%. Our table of critical values for the normal curve when z is positive gives us the proportion between a z-score of 0 and the corresponding z-score, which is basically half of that red interval. So half of 95% is 47.5%. So what we need to do is find the z-score that corresponds to an area between 0 and it equal to 0.4750. So we have to look in the body of our table and get as close to 0.4750 as we can get, and in this case we can actually get exactly 0.4750. So we notice that we're in this row that has a 1.9 in the z-score column, and we're in the z-score column, yes, and we have a 6 in the hundredths place. So we see that that corresponds to a z of 1.96, and that's the critical value that I used to determine the width of my confidence interval on the previous board.